Jai Hind everyone. Today we're going to study statistics. In this chapter we're going to study about the measures of central tendency, namely mean, median and mode, and then in the coming minutes we're also going to study about cumulative frequency curves. Now assuming that we all know the concepts of mean, median and mode, let's quickly move on to study some of the methods used to calculate mean. The first method that we use is the direct method. Now this is just an overview of the methods that we've already done in class 9 and 8, wherein mean is nothing but sum of observations divided by the total number of observations. Now as we know that frequency is nothing but the number of times an observation appears, so mean or mu as you say can be considered as sum of frequency into x upon sum of frequency. Now what is this x? X, let's quickly revise. It is the mid value of each class interval, and as you can see here, the first class interval is 4 to 6, right? So the midpoint is obviously going to be 5. Then 6 to 8, the mid value is 7, x, 7, or also known as the class smart. Similarly, if you move on in the same fashion, you get 8 to 10, the mid value is 9, then 11, then 13. And one thing that you should all remember here is that they are all increasing in the same fashion as the class intervals, right? And then you have f into x. The first frequency into x is 6 into 5, 30, then 12 sevens are 84, 17 into 9 is 153, and so on. You add up and you get summation fx upon summation x. Summation fx is 442 upon the total frequency, which is 50. 442 upon 50 comfortably gives you 8.84 as the answer. Now this is a very basic method. Now let's move on to the assumed mean method. Now this method is a very interesting method, A, because it reduces your calculation to the bare minimum. Secondly, this method assumes or tells us that for any perfectly sampled data, the mean is going to lie somewhere in the center of the observations. So let us quickly assume that we have a mean from among the central values of the observation. Now you all should always remember, children, that mean is nothing but a value picked up from the observations given to you, right? And is never the frequency. So for the given data, with the class interval is 10 to 15, 15 to 20, 20 to 25, till 35 to 40, and for a given set of frequencies, we have first calculated the mid values. 10 to 15, the middle value is 12.5, right? Now, each class interval is at a difference of 5. So comfortably, you can see that each mid value is also at a difference of 5, right? Now here we've got how many, can you see? 6 values or 6 different class intervals. The middle value amongst these x should be our assumed mean. Now the mid value here can be either 22.5 or 27.5, you take any. So let us say that the assumed mean is 22.5. A, the assumed mean is 22.5. That is, it is my assumption right in the beginning that my mean is going to lie somewhere around 22.5, right? Now, instead of doing fx, right, I'm first going to find out, before this important step of multiplying frequency with x, let me just use this assumed value to find out how much each value is deviating from this assumed mean, and hence we find out d, that is the deviation, which is equal to x minus a. That is, you subtract each mid value from this assumed mean. That is, you find out d is equal to x minus a. Now if I want to find out the value of d for each mid value, so you do 12.5 minus 22.5, that makes minus 10. Then you have 17.5. Subtract 22.5 from 17.5 and you get minus 5. Then you get a 0, 5, 10 and a 15, right? It doesn't matter to me whether a is bigger or a is lesser, right? Now, instead of multiplying frequency with x, I'm going to multiply my frequency with the deviation, and hence I'm going to find out D. I already had an F with the measures as 2, 7, 9, 8, 6 and 4, and then I'm going to multiply FD, right? Now once you multiply FD, you get an answer as 2 into minus 10, minus 20, minus 35, 0, 40, 60 and 60, right? Now as I said, whatever we multiply with F, that sum is to be taken up. So we have summation FD upon summation F, right? Now, don't you think it's a deviation from a usual formula? Yes, absolutely. So to counter that deviation in the formula, because we subtracted A first, we're going to add this A to the final answer, and that is A plus summation FD upon summation F. Right? So you add up A, 22.5 to the final formula, which is 105 upon 36, and when you calculate it is 25.416. Now one beauty of this method is that I actually had to do very less calculation on the paper. Most of the calculation was oral, right? Now another method to make the calculation even simpler for you all is another just extension. Can you see there is something common in all the D's here? What is that? Minus 10, minus 5, 0, 5, 10, 15. Yes, you got that right. They're all multiples of 5. And where has this 5 come from? If you observe, it is the class size. So if I divide this D by class size, so it's going to get, look at this, I'm going to get, look at this D, 1, 2, 3, 4, the fourth column there, D is equal to X minus A upon I is the class size, where I is 5 here, you get minus 2, minus 1, 0, 1, 2, 3. And then instead of multiplying with F and the earlier D, I'm going to multiply with the new D. And the new D gives me a different answer. Is that okay, children? Right? And then the formula goes again, summation FD upon summation F and A plus, because we had subtracted this A. Now what other thing have we done? We have divided by the class size. Now once we have divided by the class size, it becomes our responsibility to multiply it, and I do an I here. You can see that you get the same answer for this. So this method actually saves your calculation even better. Another thing that we're going to do is the median. For the median, you have a formula which is L plus n by 2 minus Cf upon F into H. For that, you should know the method to find out cumulative frequency. Now, as you can see here, we first find out what is the total value of the frequency. The total value of frequency here is 3600 divided by 2, and you get 1800. Now, we see if 1800 is actually a cumulative frequency value for us. In case it is, bingo, go on, select that class interval. But in case it is not, then you need to select a class interval that contains that cumulative frequency. L here becomes the lower limit of the class interval, and your frequency is the frequency of the selected class interval, whereas CF is the cumulative frequency of the class interval preceding the selected class. Let's move on to mode. Mode is nothing but, you can say, the most popular item in the data, right? That is, in usual day, you can find out that mode is nothing but the result of a survey. Who won maximum, right? So, the method to find out mode is look for the class interval with maximum frequency. This precisely is the modal class. Now, note down the following. Li, lower limit of the modal class. I, width of the class interval. F0 is the F1. Let's do F1 first. You can see F1, the second last thing from there. It is frequency of the modal class, and then the preceding one is F0, the succeeding one is F2, and you put in the formula L1. So mode is L plus H, F1 minus F0 upon 2F1 minus F0 minus F2, wherein you just have to put in the values, right? Then comes the empirical relationship between mean, median and mode. This formula you can use to find the third entity in the central measures of central tendency, that is for a given data, if you know the mean, the median, you don't have to really find the mode, and the other way around. Now come to cumulative frequency curves. There's something called ogive, which is a cumulative frequency curve. Children, these ogives are nothing but methods to represent how the data is changing over a period of time. If you make up cumulative frequency in a less than fashion and you plot it against the upper class limits, you know, the concept here is, you know, you must have heard this statement, less is more, right? So less is more means lower than frequency, that is the less than cumulative frequency is always plotted against the more than, the upper limit in the class interval. These are called less than type ogive. A similar graph which is made for more than cumulative frequency is called a more than type ogive. This is the method. We mark the lower limits of class interval on x-axis and corresponding cumulative frequency on the y-axis, choosing a suitable scale. Then plot the points with axis on the lower limits and ordinates as cumulative frequency. That's just another explanation of the graph. Join the points by a freehand smooth curve. Now let's underline this point, freehand smooth curve, and the curve that we get is a cumulative frequency curve or the more than type ogive. It looks like a slant downhill. Another method between median and ogive is that the meeting point of both the ogives is the median. You find the meeting point and the x-axis part, that is the x-coordinate corresponding to that meeting point, gives you the median. You can also find out the median by finding the mid-value of the graph and the x-coordinate of the corresponding point in both less than type and more than type ogives. So children, if we want to quickly wind up the chapter, we can say that statistics has different types of data, which is ungrouped, and you have grouped data. Then you have measures of central tendency, wherein you have types of mean, median and median. Median can be found out by more than ogive and less than ogive, whereas for finding out mean, we can do direct method, assumed mean method, or the step deviation method, depending on the data that you have. So that's all for today. Thank you very much. Have a nice day.